Hello everyone. We have these two event speakers, this one here and this one here. I just opened them quick after the customer left them, and they did quick check, so I can have the idea what we talk about the price, and we are gonna fix them. So this speaker is look like being open before, because there is the marks, screwdriver being touched with the screwdriver before. Like the marks here. Plus I find one of the speaker, I found a bag with the two capacitor and rectify bridge here. Yeah, this speaker here, it's the quick check it. I see the fuse is blown, so we are going to replace that fuse after we check if there is a short. Been some works done on these ones. Plus we need to solder this LED wire. All right, we put it in the ohm, so the fuse is bad, is open, and we are going to check the input of the rectify bridge and the output of the rectify bridge. So the input of the rectify bridge, it is short because the rectify bridge is connected to the transformer. It's not like the TV, the rectify bridge connected to the outlet plug. This one is connected to the transformer. And transformer is just a wire, that's why it is short. So we be sure we are going to disconnect one of these plugs here, then we test it again. So there is no short in the input rectify bridge. So this is the input of the power. Let's go to the fuse. Then the output of the fuse is come to the, like there is a switch here, on off switch, and is go to this wire. The other one is the blue one here. Must be connected here, yes. So these two wires here is connecting to the transformer. So because we have no short in the input rectify bridge, I'm going to go ahead and replace the fuse and see if I have any sound. The fuse is a 5 amp. And here is another one. Yeah, it's a 5 amp. I'm gonna connect the speakers inside. So let this one here. I hear the first peak in the speaker. So let's play something on the phone. Speaker works. I just have to fix this LED light here. And put it together and it should be ready. Then we go to the second one. Let's set up the power supply about like 1 volt and 300 milliamp, and let's check here. So no light, and we're gonna increase the voltage till maximum like 3-4 volt. Yeah, it's nothing. The light is not on, so let's flip them. I just want to see where is the positive, where is the negative. Plus I want to check this. Okay, yeah, the light is on. So this is the positive, this is the negative. So the one which has the black strip, the wire that has the black strip, it should be the negatives. And the positive is here. Alright, yeah, the light is on and the speaker works now. So I'm not going to put the board in this speaker yet till I may use that board to see what's wrong with this one, so I can try to get both of them fixed. So a quick search, I found the schematic online. That's the model number, and that's one is over there. Yep. So exactly, and the schematic is here. It's kind of simple amplifier. We have the power supply here, and we have the signal filters here, and this is the amplifier ICs, and we have a regulator for the LED front light. That's all. So this section it work here. We're going to check the power, and we check the signal. Okay, let's start with the. So this is the AC power N. We have fuse, we have the power switch, and we have two wires this side, two wires this side is going to the transformer. The output of the transformer, we have three wires. Should be one is the ground, then one is going to go to the negative, one is going to go to the positive. This is the rectify bridge, and from here, from the rectify bridge, we are going to have these two big capacitors, and we have the positive voltage here, and we have the negative voltage here. So here they don't show. Usually they show how much we should have the output here, but most of the time it should be like 30 to 40 volt around the positive and negative. And we need this VPA plus and VPA negative, because that's what the IC amplifier. Let's go to the top amplifier here. You can see the amplifier. That's the voltage that's going to make the amplifier work. Here is VPA plus going to the number 1 and 5, and VPA negative is going to the number 4. The signal, after it passes all the filters and the ICs, filters, resistors, and capacitors, is going to go between the number 10 and number 9. That's the 2 pin for the signal, and this pin here is for the mute. Number 7 is the ground. So that's a simple design. So let's check here if we have VPA plus and VPA negative. Well, then we start from here to here. When we reach here, we are going to be sure that this section is good. All right, here we should have 120 to the input. So this 120 is passed the fuse. Let's go here, then go here and pass the switch to here. So the switch is off. Let's turn on the switch. 120. So now we have 120 in these two. So we find 120 in these two pins here. So now we are going to see if there is any output of the transformer. So the first part we tested with the EC, and we're still going to test the input of the rectify bridge. This one here, the wire, the J6 and J7, this one and this one, that's going to the rectify bridge. We're still going to test them with the EC. And we have about 60 volt here. So we have a 60 volt in the input of the rectify bridge. Now we're going to test the output of the rectify bridge. It should be a DC. The output of the rectify bridge here, it shows minus and plus. And the other side, it shows AC. It's telling you where to test. So between the plus and negative, we have 77 volt, and it's stable. So we have the voltage all the way to here, to the input of this two capacitor. It's mean the same is to VPA negative and VPA positive. And you can see the VPA negative and positive is going to this R58 and R48. R48 is here, this big one, and R58 is this one here. This one is going to go to the ground. The ground is here, the black wire. And we are going to check in the input here. We have positive 38.5. It's mean almost 40 volt. And in this resistor, the input of this resistor, we have minus 38, and that's normal. Should be one is a positive voltage, one a negative voltage. That's how the amplifiers works. And after the resistor R58 and R48, we're going to have the V positive and V negative. So the V positive, we can check them by this diode D8 and D6. This 6 is here and D8 is here. D8, there is no mark on it. So here we have positive 18. And here we have negative 18 in this diode. So the negative 18, it should be here. This is the V positive and V negative. So all this section here, it should be good. There is no short in these capacitors. There is no open lines in this part. So this power supply, it's good. So next part is we're going to test the signal. So this is the input signal, the line input. We're going to test it all the way to the amplifier. Yeah, I can just go ahead and test the signal here in the input in the amplifier, and that's going to tell me all the other parts if it's good or not. But I'm going to go one by one just to show you how to figure out where the signal is stopped. So we're just going to use this. I connect this one to this one. I'm going to go, this one is like, the signal generator is going to be my computer to generate the sound. and we're gonna follow so we're gonna play any free music, copyright, to keep following the signal. Alright, so, and we're gonna need a regular computer speaker, or you can use any amplifier, just like that one's over there. Alright, so we turn it on. So we can hear the noise. So this one is going to be the negative, and this one is going to be the positive. So the negative side is going to go to the ground. And this is not the multimeter. This is connected to here. So I'm going to turn on the amplifier, and I'm going to check if it's have the voltage. 77 volts, so it's on now. And let's trace the signal. This is not the multimeter. This is going to the small amplifier speaker. So we are going to start with, so U5, you can see, let's go all the way to here to the pin number 2. That's the input, the pin number 2. U5 is here. So this one here, the pin number 2 doesn't give us no sound, but the pin number 6, we are going to have the sound. So we start counting. We're going to start counting from here. You see the little line, that's the pad number 1 with the dot. So number 2, we have the sound. The pen 6 or the pen 7, we have the sound. Yeah, here the pen number 7, here we have the sound. So we have the sound number 7. So it's go all the way. We're going to check the U6 number 1, the output, and see if we have the sound. If we have the sound here, it means all this part, capacitor and resistor, all the way to here and all the way to here, they are good. So U6 is somewhere. U6 is right here. It's hard to see it. And we're going to check at number 7. You hear that sound? That's going to the high frequency speaker, the tweeter. This one is going to the tweeter. That's why we have that sound like that. So it's mean this one is good. Number 7, the output of number 7 is good. That's where we test the high frequency sound. And it's go to R8. The R8 are right here, and the R8 right here. This is, we got the sound this side, and the sound is very far the other side. Yeah, and the R8 is about like 2 kilo ohm. Yeah, the sound, I can hear the sound in this IC, but the sound is far. So that's the high frequency. We have the sound coming all the way to the amplifier. The sound coming all the way to the amplifier. And here we start the low frequency and the chip number 7. We go ahead and check the output. And if you can see here, the U7B and U7A is mean one chip. It has 2 logic ports. So the input 5 and pin 5 and 6, and it's go out to the 7. Then from the output 7 is go to the 3 and 2. Then the output 1. This is one chip. It has 2 logic ports. So we go to the pin number 1, and if we have the sound in the pin number 1, it means all this section is good. So U7 is here, and we're going to go to the pin number 1. We have the sound. So it means the IC, it has the power, IC works. The UHA and UHB, we're going to test the output of it is in the pin number 7. If we have the sound in the pin number 7, it means all this section, it's good. With this one here too, this switch. So let's go to the number 7, UH. UH is here, and the pin number 7 is here. We have the sound. So from the pin number 7, we have R62, R20, then we have the pin number 10 to U2. So here is U2, and R20 is here. So one side of the R20 we have the sound. One side of the R20 is right here, we have the sound. Here we don't have the sound. And that's going to the pin number 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I can't hear the sound, but maybe the R20 is lowering the sound. So making the sound very low isn't this hard to detect. But I do have the sound in the R20 one side. I'm still going to check the resistance in that R20. It should be 2 kilo ohm. That's what is the schematic set. The R20, 2 kilo ohm. But we have the sound all the way to the R20. And we are going to check the sound and the R43. R43 is here. Yeah. You can hear the sound over there, it's kind of strong. Here I don't hear it. So that's good. R43 we have the sound. Then R56, the input of R56. The output of the R56 we have the sound. R56 is very small resistor over there. So R56 is right there. R43 is right there. R20 is right there, and R8 is right there. So I'm still going to check because we have the output sound in all of the other resistors except the R20. Let's check the R20, what's the resistance in it. Let's go to the multimeter. So we wait for the device discharge before we can test it. As you see, this is a 2 kilo ohm, but it's tested as like 10 kilo ohm, or here, this one 2 kilo ohm. Tested as a 12 kilo ohm. So this one here. 18 kilo ohm right here. This is 2 kilo ohm. This one is 2 kilo ohm. So R8, yes, these two resistors they test high. You should test it as a 2 kilo ohm, as the schematic show. Well, let's go. Let's check the voltage. So the voltage in the amplifier, is a VPA plus and VPA negative and the ground. That's the voltage that the IC need to work, and that we can check them. And the D1 and the D2. So let's put, you can see here D1 and D2 diodes. 38 minus 38. D1 and D2 should be VPA plus and VPA negative. No, both of them, they don't have no. Yeah, both diodes, they don't have no voltage here. Minus 18 here. Plus 18 here. Yeah, we have the voltage, but why we don't have the voltage here? Okay, we have 38 here. We have 38 volt in this diode. We should have minus 38. So we don't have that. The IC, it has the number 1 and 5 is V plus. Number 1 and 5. V plus is 38. So all the ICs, they have 38. And so let me take the board apart and we check the other side of the board. So in the D2 diode, it should be connected direct to the rectify bridge, VPA negative. And here, VPA negative. Yeah, it should be connected direct to it. So let's check if there is a connection over there. Because we have no voltage. We have the other voltage. We have the VPA plus is a 38, but we don't have the VPA negative. The VPA plus, it's here. You can see there is a good connection. VPA negative is from the cathode of this diode. The VPA plus is from the anode. The top of the diode here, and the other one of the bottom of the diode. So right here, we don't have connection. So there is a broken connection from here to here. So the switch is here. And this one, it's here. So let's connect it nicely. 77. That's good. Okay, let's do it again. We try the pin number 4. Carefully, the pin number 4, we have no connection. We have 0.9 volt. The pin number 9 here, or the pin number 4. All of them should be like 0.9 because all of them is connected together. 0.9, 0.9, and that 0.9 we are going to find it here. 0.9. All right, so we don't have the connection from the net positive to this diode is good, and from this diode here to the pin number 1 it should be good here. All good. Pin number 1s in this IC is all good. Then this one to here to the pin number 4, it's good, 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 good. But from here all the way to here, or all the way to this resistor, no connection. From this resistor to here, there is a connection. So that's why we find the voltage here. We find the voltage here, but we don't find the voltage because there is no connection from here to here and from here to here. But why is that? And we know that the customer changed this, I don't know, another technician changed these 2 capacitor and the rectify bridge. So let me check these 2 capacitors. The rectify bridge solder is good. Could be like a bad solder, maybe. Let's check these 2 capacitors.
Yeah, the rectify bridge solder look is good.
Alright, let's check these 2 capacitors. We check them to see if they are good, and let's discharge them. Yeah, this video is going to be a little bit longer. And maybe one of the capacitor is weak. That's why we do, but at least we should have the connection. I don't think so. Yeah, the ESR is a 0 ohm, and is a 98,000 or 9,800 microfarad, and this is 10,000, so it's very close. For anything over 90%, the capacitor should be good. Yeah, don't forget to discharge the capacitor before you test it, because you may burn this device. So the same thing, 9,800 microfarad and 0 ohm ESR. So the 2 capacitors are good. Could be a bad connection, maybe. Maybe that's why when I was taking it apart, the fuse burned, because there is a bad connection. Let me test something here. This board is a 2 layers, the top and the bottom layers, and there is a bridges between the 2 layers. In these holes, there is a copper inside them that's connected from here to here. all the way to the bottom. So, and I don't see no new solder here. This pad here is connected to nothing, it's good. So we are not worrying about this one, but we are worried about these 3 pads. So let's check. We're gonna check from this side, or this one. This should be good here, because they have a big trace from here going to here, and is connected to here. You can see these 2 sides connected all the way together. So and that's the ground. All right, this side here we are not worried about it because it's nothing connected to it. You can see there is no trace in the top. This one, it's good. It's go all the way from here. Yeah, this trace is good. Let's see this trace here. This one here, it's connected. Let me see what is connected to. It's connected to the negative side. So from here, it should be connected to the negative side. And it's not. And you can see it's connected to here. This one is not connected to, but it's supposed to. Oh, that's why. So this one here, look, is connected, but it's not connected to here. This one is connected to here, but it's not connected. Same what I was thinking. The little bridge here is missing between the connection from here to the bottom. So we should have a connection from here to the bottom. So let's look at these capacitors. Yeah, this capacitor, you can see this ring here is from this side. And you can see here that there is a capacitor. Let me show you. That copper bridge, it's right here. This is the copper bridge. This copper bridge should be set in the board. But this side is good because they already have this big ground here connected to the other side. It's grabbing the connection from the top to the bottom. But this one here, there is nothing grabbing the connection from the top to the bottom of the board. So maybe this capacitor here. Yeah, you can see both of them is here. Yeah, you see them? Both of them is here. And here is the other one. This ring of the copper here, it should be set in the board. Yeah, you see it? That one over there. So you can see there is a 3 dots here. So there is a 3 dots here that's grabbing the connection from here to here. It's the 3 dots. But these 3 dots, it's not connected to here to the bottom. It's not connected, but it's connected here. Yep. So what are we going to do? We're going to do a jumper from here to here. So let's solder these two good capacitor back. So we have some kind of the connection here. After we make a solder, maybe the solder go the other side as well, but we are not going to trust that. We are going to make a wire jumper. Right. So let's put it together and we test it. Yeah, I hear some sound. It works. And that's what it was the problem. So let's check the tweeter. It works. So that's what it was the problem. The technician that replaced the capacitor, he didn't pay attention to that bridge, and that was missing the connection. So now if we check here to the pad number 4, or this side of the diode, we have minus 36 volt, and this side of the diode plus 36 volt, and that's going to the amplifier chip. Here is minus 36, here is plus 36. So I'm just gonna go ahead and replace this fuse, put the device together, and the two speakers are ready. So I resoldered the varistor. So this all for this video. Thank you for watching, and see you again.